Well, welcome back, folks. Thanks for joining Tobias and myself as we walk you through querying SQL Server 2012 and trying to show you some cool little tips and tricks for getting the most out of your databases in SQL Server 2012. We're going to move into another module here. It's going to be talking about aggregating or grouping and aggregating data. We've gone through some pretty much some fundamentals, some basic information about SQL Server, try to again level the playing field. We've introduced some of the advanced select statements. We talked about SQL Server data types in the previous module and the importance of those as you're creating your objects and understanding how they're going to be used. What we're going to do now is looking at aggregate functions. I call them aggravating because sometimes they can be that way, and as well as grouping by or group by and having clauses. We'll talk about subqueries, both all the self-contained, correlated exist, and we'll take a look at a view, creating a view, and we'll look at some of these tables. We've had some questions on inline tables and some derived tables. We'll talk about that in this section as well. So we're going to head right on into that and have a conversation to begin with on aggregate functions. And there's three categories of these functions. There's the common ones that we'll see, like the sum and the min, the max, the average, the count. We have some of these statistical ones, and for Friday the 13th, I'm glad I was able to say that. Standard deviation, for instance, and we have the var, the varp, and we have some other ones like grouping and grouping ID that are available for us as well. So we have these categories of aggregate functions that we have available to us. If we begin working with aggregate functions, they return a scalar value with no column name. They're going to ignore nulls most of the time with the exception of the count. They can be used in the select statement, the having, and the order by clauses. They're frequently used with the group by clause. We have an example of a select count, distinct sales order ID as unique orders, and we have average unit price as a column name, minimum order quantity, and we have maximum line total for a particular line item. And we're retrieving this information from the sales order detail table. And as you can see, an example of the results are on the bottom here, where we have 31,465 unique orders. The average unit price is $465. We're getting that from the average there. The minimum order quantity is 1. I would hope there not be a detailed line order detail for a 0 order quantity, so I was glad to see that as 1. And then the max line total is 27,893.619000. So we did get a retrieval of content from, and this contains 4 aggregate functions within one statement, which makes it nice that we can summarize that content and kind of give us a display instead of looking at 31,000 records plus to determine what's going on with the number of items in that details table. The distinct clause, we talked about that. We've introduced that a couple times with aggregate functions, provides you that summary of information. It aggregates, and during the aggregation, it eliminates those duplicate values, not rows, but it eliminates the information that would be normally provided. And we have an example here. Again, we're doing a count on distinct customer ID, and we're using that information and then returning information about the salesperson ID, the order year, all customers, and any unique customers. So we're trying to find out per salesperson how many customers they have as a whole, and per year how many unique customers they had. So this is what the query will do for you with this aggregate function using the distinct clause.
Okay, I'd like to just show something here to kind of disambiguate a little bit between the various things you can use. And again, I apologize for what my...
Your monitor freaking out on you?
Yeah.
It's like, come back.
I logged out and then it was all fine.
Okay.
So just looking at this distinct and aggregates and group by. So let's say I just get all orders, right? There we go.
Okay.
Now I want to get, let's say what I want to get is I want to get really maximum of 1 order per customer. So I'm interested in this distinct thing per customer. So I can try and just calculate it. So I'll just do count distinct customer ID. So now we'll know, okay, this is how many customers are referenced in this table. Okay, so 19,000 something. What if I now want to have 19,000 rows returned, but I want the customer, so 1 order per customer.
Right.
But I also want other information. So I can try and do group by, and I'll say, okay, give me give me everything, and I want to group this by customer ID. Well, this doesn't make a lot of sense, right? Because now you're saying calculate some aggregate for every customer. So I'm expecting to get one row back per customer, but we're returning details, right? We're not using aggregates. So I could then say, okay, give me just customer ID back. And now I'll get just the customer ID, and I can say use an aggregate like count star or something to get the number of rows. But I want the details in this case. If I try and use distinct over this, then I obviously do distinct over the entire row. What I can do is use this row number thing that's very interesting for this problem. So again, what I'm after is give me one order per customer back. So basically the first or last order for every customer, but I want all of the order details. So I'll say select star from sales order header, and I'll say, okay, please calculate now the row number over partition by customer ID. So basically start counting again when it's a new customer ID, and order by, let's say I want the newest orders first. So I want the latest order for the customer as row number. Okay. So this will just execute and calculate the row numbers for me. Now, what if I just want to have now the first for every order? You would say something like, well, give me where, because I know I can't say where RN, because that's not defined yet, right? So I'll say, okay, where row number, blah, is equal to 1. Well, it gets me an error back.
Yeah.
Why? Well, because row number and all of these ranking functions and aggregate, all of these ranking functions, they are calculated at select time, right? So in the where clause, we have no idea what this row number means, because obviously if I change the where clause and if I say where, ooh, that's fat fingers.
I don't know what that was.
If I now say, sales order ID is less than 1,000, that will be part of the query. Now the row numbers change, right? They're based on this filter. So what I can do instead is I can say select star from this set, and now Rn exists, right? So now I can say where Rn is equal to 1. So what does this mean? Well, it means get me all of the orders, calculate the row number for each order per customer, right? And then give me only the first. So this means give me only the first order for every customer. And now I should get this 19,000, we can see down here in the lower right-hand corner, 19,119 rows back.
Right.
So that's an interesting thing from this. One is using window functions, row numbers in this case, as well as what does distinct mean and what can you accomplish. So it very much depends on what you're after, if you want to use distinct, count distinct, or something such as row number to grab the latest orders. If, let's say I wanted to get all orders that are made in the same day. Now row number, if they're made in the same day, they will get different row numbers, right? 1 and then 2, 3, 4, even if they have the same value and randomly in the order we find them. But if I would say rank, now I would get multiple orders or rows, because I will get for all of the orders that have the same order date, they will come back with the same rank. So rank 1 can now be multiple orders. And in this case, let's see if there's this case. Yeah, so now I got a few of them are on the same day.
Yeah.
So 19,127 rows back.
Very cool. All right, so we have the group by and having clause that we're going to be working with, and this is going to kind of, again, we're working with the aggregate functions and ways for us to create summary data and get that summary data. So we're going to continue on talking about the group by and the having. Having select and order by must return a single value per group. All columns in the select, having, and order by have to appear in the group by clause. So you have to be aware of that. If you're going to use a column in the group by clause, it's got, if you're going to use a column in the group by clause, it has to appear in the select, having, or order by. So if it has to be have appeared up there already. With the logic order, we've gone through this already. We've seen this a couple times, and how the statement is actually processed, the from, then the where, the group by, the having, back up to the select, and the order by being last. It's very, very important for you to understand that. If you're using the group by, all the subsequent phases operate on that groups, not the source row. So it's going to work on the group information, and that's why that order is important to understand here. This one here is actually just getting a count. It's going to display it as a count as the header for it, and we're going to group by customer ID. So we're trying to see how many customers that we have. We're going to group by customer ID, and then the second statement here. The aggregate function is going to refer to any columns, not just those in the group by clause. So we're going to select product ID, max order quantity as the largest order. So when we run this, we're going to group it by product ID. So for each product ID, we're going to see the maximum number of items ordered per product. So this allows us to use that max aggregate function to be able to return that content to us. The having clause provides a search condition that every group in the group by clause must meet, and it's processed after the group by. So what we're going to do is we're going to select customer ID and we're going to do a count as count orders from the sales order header table. We're going to group by customer ID, and then we're going to say, oh, all those that are grouped by customer ID, once that group is created for each customer ID, having a count greater than 10. So if we have less than 10, we don't want to really see much about that customer. We want to see only those items that are returned to us, those rows that are returned to us when they're in those groups that are greater than 10. So we'll do a count on those customer IDs that are returned to us, and then we'll return the result set with those items that have more than 10 in that count return, the count orders field to be more specific here. If I want to compare, so we've talked that the having and the where are similar, but I want to compare the two. The where filters rows before the groups are created. The having filters the rows, which controls how the groups are going to be passed to the next logical phase. So if we look at this, we're going to use a count expression in the having clause, and this is going to be useful to really provide a solution for common business problems, because this is going to show only customers that have placed more than one order. So in this case here, we're doing a select customer ID. We're going to do a count on that from the sales customer as customer, and then we're going to join that table, and we're going to join that table to the sales order header, and we're going to give it a table name, an alias, and then we're going to group by customer ID. But then we want to only see the content where a customer has placed. We're going to see content from multiple columns, but we're going to see only the rows returned to us where a customer has more than one order that's been placed. So it's going to give us a situation to find out who our repeat customers are. We could even take it up a notch and say having the have count with more than or equal to 10 customers. So again, we're trying to see maybe at this point who our more popular customers are, or busier customers are, and we'll get that information returned to us by taking advantage of some of these statements that we're showing here. So the group by and having clause, is there another, we kind of just did that one. Is there another demo on the group by and having we want to take a peek at? That was the last one. It's pretty cool. If there's anything specific that you wanted to show us. If not, we'll just move on.
No, I think we're fine.
Okay, we're good. All right. Let's talk subqueries. Subqueries could often be a little bit confusing because you're looking at a query within a query. So with the subqueries, we have to be careful and aware of how they work, and there's a few different flavors of subqueries that we have associated with this. So they're really nested queries, or as I mentioned, queries within queries. The results from the nested query are passed to the outer query. So the inner query acts like an expression that's going to be returned and used by the outer query. The subqueries can be self-contained or correlated, where self-contained has no dependency on the outer query. The correlated subqueries depend on the values from the outer queries. Subqueries can be either scalar, multi-valued, or table valued. So we'll take a look at a scalar subquery here. We're going to do a select order ID, product ID, unit price, order quantity. From the orders detail, where the sales order ID equal, now we're going to use the subquery select max sales order ID, and we'll return that in the column called last order, and we're going to get this information from the sales order header. So what this is going to do, it's going to query the sales order header. It's going to look for the max, aggregate function max, for a sales order ID, and it's going to return that as the last order, and we're going to see what information on the last order that was just processed. And as you can see from some additional information, if the inner query returns an empty set, the result is going to be converted to null. And the construction of the outer query determines whether the inner query is going to return that single value. So we actually have that where we have sales order ID, product ID, unit price, and order quantity, where sales order ID equal, and then we have the subquery, which is going to return and determine what that sales order ID is, so it can process that order ID. Now with multi-valued subqueries, this one's a little off keel here. The multi-valued subquery returns multiple values as a single column set. So what we're going to do is we're going to use the in clause here. We're going to go and query the sales order header. We're going to where customer ID in, well, in what? Well, we're going to perform another select statement. Select customer ID from sales.customer where territory ID equal 10. So now we're going to return content, or the outer query will be performed based on the idea of what customer ID or territory ID equal 10. So it's going to return that content for us, or perform that query for us based on that subquery. The keyword exist also could be used, or not exist, as you can see here. This is select customer ID and person ID from the sales customer, and we're going to rename that as cust. Where exist, what exists? Well, we're going to do a select asterisk. So we can't use column names when we're using the exist. We have to use the asterisk, or return all columns. From sales.salesorder header as ord, so for order, where cust.customer ID equal order.customer ID. So we're going to do a match on customer ID from the two tables in the subquery. If it exists, then we're going to return that content to the outer query, and that content will be displayed. The customer ID specifically and the person ID will be displayed that way. And we can flip that around and do a not exist as well. And both of these will provide us information regarding the exist, or regarding the content that's returned from within that query or that subquery. All right, a demo using subqueries. Let's jump out here and take a look at just a couple of those items that we just looked at. We'll jump back into SQL Management Studio. We're in Module 4. I'm going to close this out here. And let's open up one of my other items here. And so here's a couple items here. So this uses, that's the one that we had shown that uses several of those different, that has the count, the average, the min, and max. So we can execute that here, and you'll see it comes back with unique orders, 31,465, average price, min order quantity is 1, and the max line total for a particular order was 27,893. This one will return the all customers and unique customers for a salesperson. We saw the text for it, or the command for it. I just want to execute it so you see the results for it. So salesperson ID, we have a few null values, but salesperson ID 274 in the year 2007 had 14 customers, 13 of them were unique. 2006 had 20 customers, all of them were unique. And same with 2008 and 2005. And again, we ordered these by salesperson ID so we can see how each salesperson is doing. This here shows us a count of all customers and then sorts them by salesperson. So we'll execute that. Here's the salesperson ID. So salesperson ID 274 has 48 total customers. 275 has 450 total customers. So this kind of gives us a quick count on how our salesperson people are doing, and we can compare that to taking a look at the number of customers that they have. Here's the group by and the having clause that we saw an example of. We'll go ahead and execute that. Here's the customer ID, and we're ordering it by count orders instead. So customer ID 11091 has 20 orders that we have, and we're just doing the count. And we're only looking for those items greater than 10. Again, we're looking for our more popular customers, the ones that have at least 10 orders in this particular situation right here. Here's the information. It returns information about the last order that was submitted. We saw the query for this. We're going to execute this now. And they're saying the sales order ID 75123 was the last order that was submitted. There were 3 products that it ordered. The unit price of each of them was $21.98, $159, and $8.99, and they ordered 1 item. So this is the last order that was submitted by And the sales order ID was 75123. They ordered 3 different products, the price for those products, and the quantity of those products that they ordered. Didn't spend a lot of money there, unfortunately. This one's going to return all the sales orders for each customer in territory 10. So now we're going to narrow it down to a specific territory. We want to see what's going on in a specific territory, maybe with a sales manager in that territory. So customer ID 20042 has a sales order ID 43708. So it's going to return information. We could add additional information here. Notice it's returning 3,200 rows. And so this would give us information specifically about a territory. In this case here, territory ID number 10. We're going to look at each customer and each sales order ID associated with each customer to find out what kind of activity has taken place in territory number 10 and only in territory number 10. And again, we could have swapped that out and used additional territories by changing that clause up there. This is going to display the person ID for every customer who has placed an order. This is that exists clause. And we'll go ahead and execute that. So customer ID 1100, the person ID was 13531. So every person, this is the person ID associated with the customer ID for each customer that has placed an order. The exist says an order had to be placed. So a record has to exist in the sales order header number or table in order for them to be returned here. And you'll see we have 19,000 rows available for that. And that's getting ahead to the next section. So this is different ways for us to be able to query content. Specifically, we're trying to use content that is
Brian,
a subquery.
Can I show a demo?
Yes, absolutely. You could show a demo.
In
In fact, the demo slides up just for you.
Oh, wonderful. Okay, so I was just sitting here tinkering and thinking, so I thought we should show something. And also looking at some questions being asked. So I wanted to just show this example of derived table and what we also call common table expressions that can be super useful. So actually, let's just take the example that I showed before with row number.
Okay.
So we can just start with that and just copy this thing over. So again, this is called a derived table. So basically, it's a set that you query from. So you use the subquery in the from clause or the join clause for that matter. So you can say select from a table, inner join, left join, derived table. That works perfectly. And in this case, this was practical for us to figure out get us these orders based on or the first order for each customer. There is another way of writing this, which is also very useful, which is using a common table expression. What the problem a little bit with this is, if you write a big query now, you can imagine how it can look something like this, right?
Pretty complex.
Exactly. So if you're trying to make sense of it, that can be somewhat tricky, right? So instead of doing that, you can use this common table expression thing. So in that, you declare these views, if you will, or derived tables or common table expressions first. So I can say with A as this is my set called A, and I can just copy this thing in there, and now I have A available to me, and then I can do my select star from A, and where row number is equal to 1, or rank in this case, since I'm using rank. And it's exactly the same thing. There's no performance difference or anything like that. But you can imagine now, if I have a lot of these, right, you would have something that looks like this, and with commas up here just separating the sets. Now my query itself is pretty simple. I would, I will join A with B on something, and then I will do left join this with this other thing. So it becomes a lot easier to follow the logic of the query if you write it like this rather than as a derived table. So let me show you an example also of this with group by. So let's say I want to calculate orders, number of orders per customer, this very simple thing. So customer ID, comma, just count star. So just number of orders per customer. Sales order header, group by customer ID. Okay, so I have this query. Now let's say I want to do something actually a little bit different. Instead of using customer ID, I would like these grouped by a calculation instead. So let's tie these together. So this is something I typically do, so I often forget what the columns are, so I can just do this, and now I'll easily find the columns. So let's say we say, okay, status 5 is okay, and all other statuses are not okay. So in that case, I'll say something like case when status is equal to 5, then I want to return okay, else I'll say not okay. Okay? End as status. And since this is a group by, I now need to go and group by exactly this full clause, right? So I need to put that there as well, because again, this column alias status isn't available in the group by clause because this is really what we're typing, right? Logically, we're starting from, then comes group by, and then select. So I'll go and execute this. And you can see it works nice. Well, okay, we don't have anything. Not this status seems super useful, so let's not use that. Let's use revision number instead, just for the example. Okay. Oh, sorry. Is equal to 3. That's this case. There we go. Okay, and some not okay. Now this is obviously somewhat irritating that you have to repeat the case expression. But with a derived table or a common table expression, I don't need to. I can say with a as, I define the expression, and then I don't have the count here anymore. This is just this is the full set that I need, right? So I can do a select star from A, which works fine. I get all of the rows back. And now, obviously now, status is a normal column, right? So now I can just say, okay, from A, group by status, and I would like to get the status, and I want the count. And now this works fine, right? So these common table expressions or derived tables can greatly help you simplify your queries. Now you may ask, ooh, isn't this less performant because clearly we'll generate this full set and then you'll go ahead and basically do the calculation on top of this. So what we do in the query optimization is one of the big first steps we do is flatten the query. So it's not always the case, but typically, however you write it through a view, derived table, common table expression, when it hits the query optimizer, it's just like the flat query that you would have written directly against the table with none of these. So they shouldn't actually affect performance.
All right, excellent. Thanks very much, Tobias, for explaining that for us. We're going to talk about some table functions and focus just on some of the details on using table functions. We're going to begin by talking about a simple view, and this is very simple. And remember, a view is not an object that's stored in a database. It's really an object that, it's a query object. So when I go out and execute a select statement against a view, it's actually grabbing the information or retrieving the information from underlying tables through this view. So we're going to create a view called human resource.employee list as we're going to select 4 rows or 4 columns from the human resources.employee, and then we can turn around and do a select asterisk from that employee list. So now I've got a view and I can restrict the view. So I may have 15, 20 columns in the employee list, and there's probably only 4 or 5 I want some individuals to see. Well, what I can do is create a view, give them permission to access the view, and the view will only return that content to them, or those 4 rows that they have permissions that are displayed in the view that they have permissions to see. Now, this is showing an example of creating a view with just one underlying table. You can actually create a view with multiple underlying tables. We could use a join statement and get information from the employee list and the employee address list if we wanted to. Or employee list, we want to see how many employees are also customers that bought some of our product. So we can actually use a join statement here to make this a little bit more complex. But this view here is just going to take 4 columns from our employee table and create a view of them. Now I can give permissions to individuals to access the view without giving them permissions to access the other columns within that underlying table. And again, I could add additional columns from other tables to ensure that my users are able to see additional content in this view. And again, they're not stored. It's not stored as an object. It's more of a query object here. The table valued functions are created by administrators and developers. We can create a name of function using the create function here. We're creating a function here for a line total. We're going to pass a parameter called sales order ID. Notice that what's unique about this, it returns a type called table. So instead of a scalar function or a value or a group of values be returned, it actually returns a table. And then it uses this as return, and there's a select statement in there, and it's going to actually use the cast to do a conversion, and then it's going to create a field as decimal 8,2, and it's going to grab the information from sales order detail, where the sales order ID equal the pass variable, whatever we passed in for the sales order ID. So it's going to match it up. It's going to execute or perform this function based on the sales order ID and compare that in that where clause to perform that function. Derived tables are named query expressions created with an outer select statement. I think we just saw a good idea of those. Derived tables must have an alias, have names for all columns. Every column has to have a name. Have unique names for every column. Are not used in an order by clause and cannot be referred to multiple times in the same query. So a few ideas about how derived tables are used. They may be internal or external aliases or use internal or external aliases. They may refer to parameters and or variables, and they may be nested within other derived tables. So there's some restrictions and there's some limitations that you should be aware of when you're looking at the use of these derived tables. We can pass arguments to derived tables. We're going to declare a variable here called empid of int type with 9. We're going to select order year. We're going to do a count distinct as customer count. And then we're going to perform the query, select year as order date, and then or select year, a portion of the order date as order year, customer ID, from the sales order table, where empid equal to past empid with the declared variable. And we're going to set this up as a derived year, and then we're going to group this by order year. And this will give us information about the order year on the distinct customer IDs and the number of items that customers purchase for a particular year. And we're going to pass the ID of that customer in as a variable when we run this or use this derived table. Now the CTEs are common table expressions. We just got a nice demo from WS on this. With CTE year as, we're going to select the year, order date as order year, customer ID. And then we're going to go in, we're going to do a select order year with a count distinct customer ID as customer count from the CTE year, which is what we decided, what we defined, with the with clause. And then we're going to group by the order year. So this allows us, and again, this is the demo, this is an example of what Tobias just demoed for us in just a few moments ago. Are there any other functions that you're interested in demoing in this particular module?
I can go ahead and demo just table valued functions and talk a little bit about that. So basically, why would you use a view versus a table valued function? And there are two types of table valued functions. There are the inline table valued that we shown on the slide, and you can also do multi-statement table valued functions, which are a little bit more complex and you can use for somewhat different types of problems. But typically, the table valued function, it's just a view. It's a view that takes parameters, really nothing else. So it's useful for you if you want to force queries to look a certain way. And so it's fairly common that you want to say, well, if you search this table, you really should search on dates because I have an index on dates. Yeah. So as an example, we may say, okay, we want a function or a view that gives us just the total purchases per customer, let's say. So let's just call this sales.fn customer sales. And we require you to take start date and end or pass and end date as parameters, and we'll use the data type date, and returns table. Now again, returns table doesn't mean we create some sort of table in some special way. It's no different from using a common table expression, a derived table, or a view. As return, and then we have this query. And obviously this is now stored in metadata, so that's the big difference from using the inline, the CTE or the derived table, that now you have stored this and you can reuse it as much as you want. So we'll just do the simple thing of select customer ID, or customer ID, comma, I think it's called company name, and then just say sum of something. So from customer table, and then I'll do a left outer join, because I want to include also customers that didn't buy anything. Sales.sales order header on sales order header, customer ID is equal to customer ID in the customers table. And then I want to go and continue running into the sales order detail table to get the actual price. So where sales order ID is equal to sales order ID. And then now I want to group this by the customer. So customer ID, and I wanted to include, okay, let's say account number as well. And I want to sum the unit price, let's just say, as a simple example. And I want, if this happens to be null, if we don't find, so if there are no orders, we'll get null returned, right? So the sum has nothing to sum up. Something weird going on here. Okay, so I'll just say, if this returns null, I want a 0 returned as total sales. So we'll go ahead and create this function, and then we require this filtering. So where the order date is greater than or equal to my start date that I passed in, and order date is, let's say, less than, just to make it easy, end date. So end date is exclusive in this case, just for simplicity. So now, obviously, I force whoever is querying my function to go and use the ordered, if I have an order date index, presumably that could be used depending a little bit on what other indexes I have on the other two tables. But I'll create the function. Oops. Some unit price. Oh, sales order ID. That's so it should be order date here, obviously. That's hard to compare an integer with the date. So now we have the function, and now we can just go ahead and query and say, well, I would like to get everything from here and starting with 2011, January, and less than 2012, let's say, or 2013. And there's nothing there, so let's go further back. There we go. There we go. So just an example of using an inline table valued function.
How many keyboards do you go through in a week, a month?
Well, I'm actually...
I see that one smoking already. It's only been a few hours.
The big problem here is, so this is, someone asked about, so this, it's not integrated, it's part of, it's a separate keyboard. But every time I go to Sweden, I always buy a Swedish keyboard. So I'm used to, I should have brought one here today, but
I'm glad you didn't, because if you're typing that fast on a US keyboard, I can't imagine how fast you type on a Sweden keyboard.
Yeah, and it will also be...
Fire extinguisher over by the keyboard.
Yeah, and I would say not select, but it's hämta in Swedish, and hämta, start, från. Yeah, it would be different, but...
Well, you're doing great, definitely. My hands are getting tired watching you type, so... all right, so let's just go ahead and do just a little bit of review for this module here. We introduced three of the common built-in aggregate function categories, the common, the statistical, and then the other category. We saw a demo on several of these as we went through, especially under the common ones and on the other column. So we went through and saw some of these examples of these. We also talked about more detail on the distinct clause. We saw some information in detail about the group by and the having clause. And we got some really good information on the demos when we did the scalar subqueries and the multi-valued subqueries. And then Tobias rocked with the table valued functions and the CTEs and the derived tables. Had some great some demonstrations on those as well. So, and we also get to peek at how to create a function, one of those table value functions, and how again we use the return type of a table, which is unique for something that we're in comparison to what we normally use. So this is going to wrap up Module 4, and what we're going to do now is take a meal break. So here in Washington, it is it's about 11:45, so we'll return at about an hour from now. So we're going to take 60 minutes, depending on what time zone you are in the world. 60 minutes, roughly 60 minutes, 45 minutes past the next hour, but wherever you may be.
Wherever you are, it's still 60 minutes, right?
It's still 60
Just
minutes
to be
no
clear.
matter where you are. So it doesn't matter where you are. It's always 60 minutes. So I don't know what the time frame is going to be on your clock. But
it's not 60 minutes in Fahrenheit, or there's something.
No, it's not
okay.
that way.
Just checking.
No.
It's always confuses me.
Yeah, regular time, thank goodness. So, all right, so eat up, drink up, recharge for this afternoon, or the remaining modules that we have, because it may not be afternoon for you. We'll be back in about 60 minutes, 45 minutes past the next hour, and we'll continue on with our discussion. We still have 4 great modules left for us to discuss this later on today, and we look forward to seeing you back here in about 60 minutes. Thanks for joining us.
Thank you.